Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahilladzi hadana lihada wa ma kunna linahtadiya laula an hadanallah. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh. Allahumma shalli ala Muhammad wa ala alihi wa ashabihi wa man tabi'ahu bi ihsan ila yaumiddin, amma ba'du. Hello students, today we discuss linear programming, that is tool for optimization in planning. We have studied before in planning the tool. We have three tools, that is the linear programming, PAP analysis, and then the PERT. And today we discuss about the linear programming. In this section, we will study the case of using linear programming in product mix problem that happened in Wyndor class company as the case study today. There are three classic applications of linear programming. For example, firstly is product mix at Pandrosa Industrial. Consider limited resources, that is because we have the limited resources and we want to determine the optimal mix of plywood product, increase overall profitability, and then profitability company want to increase 20%. In another case, we can use or we can apply the linear programming in personal scheduling. For example, here is personal scheduling at United Airlines. This to design work schedule for all employee, and then to save 6 million annually, that is the efficiency, to improve the efficiency. And then another application is for distribution, marketing, and planning of supply. Distribution and marketing, for distribution and marketing and network. Yes. That is the three classic applications of linear programming. Okay, we study firstly about the product mix. We study in Wyndor class company. They have the product mix problem. The Wyndor has developed the following new product. We have windows and door product, doors and the windows. They have two types product, and the company have three plant, that is the resources that the company have, and this is the limited resources. They have the plan 1, plan 2, and plan 3. Plan 1 to produce the aluminum frame and hardware, and then the plan 2 to produce the wood frame, and then the plan 3 to assemblies, produce glass and assemblies, windows and doors. And we have question here. Should they go ahead with launching these two new products, or if so, what should be the product mix? How many they have to produce the windows, and how many we have to produce the door? How many? For study optimization, we have this data that the door have a unit profit for the door is $300, and the unit profit for windows is $50. And to produce the door, we need 1 hours in plant 1. Plant 1 is, we know that the plant 1 is aluminum frame, produce aluminum frame. So the doors that we have, the doors is aluminum framing. The door glass door with aluminum framing. So we need 1 hours in plant 1 and 3 hours in plant 2 to assembly. In the other side, the windows have more profit than doors, but they need more hours to produce. In plant 2, 2 hours, and in plant 3, 2 hours. And this is the available hours or the available resources that we have. Plant 1 have 4 hours, and then the plant 2 have 12, and then the plant 3 have 18. So the question is here, how many doors we have to produce, how many windows we have to produce. So we get the optimum or maximum profit. How we can get maximum profit? How many windows and door have to produce? Okay, in this problem we will use the graphical method. So the firstly we have to make the model, mathematical model. Okay, we use the algebraic model. Why we use algebraic model? Because this is the linear programming, the linear equation. We got the linear equation. Okay, we chose T as the door, and then we chose W as the windows, the money or the number of doors to produce and the number of windows to produce. Our maximized profit, that is the profit, our maximized profit is the unit profit for doors multiplied by the number of doors. So too in windows, the unit profit of windows, that is the 500, and then multiplied by the unit number of windows. So this is the profit. Okay, that is the profit model. And in here we have the subject. What is the subject? Subject, that means is the resource that we have, the limiting resources. Why we restrict the number of doors must be lower than or equal to 4. Where does it come from? We can see this in this data. We have the data here that to produce 1 doors, we need 1 hours in plant 1 and 3 hours in plant 3. So to produce 1 doors, we need 1 hours in plant 1, and to produce windows, we need 2 hours in plant 2 and 2 hours in plant 3. So to produce the 1 doors and 1 windows, we need 2 hours and 5 hours in plant 2 and plant 3. That is the hours used, and that is the hours available. So we can see this, you can see in this here that the 1 is lower than 4. So this is available is 4 hours, that we use only 1 to produce 1 door and 1 windows. So we can increase the number of doors or increase the number of windows, because we have available here we have the remain 3 hours to produce a door or windows. In another side, we have available 12 hours, but we just use 2 hours to produce one door and one windows. So we can increase the number of doors or the number of windows and or. So we will increase the hours used, but the hours that we use must be lower than hours available. That is the principle of the subject equation here. So 2 times by number of windows, it must be lower than 12, because to produce every windows we need 2 hours in plan 2, and we have the 12 available hours. So the maximum we can produce the windows, because of the limiting resource that we have in the plan 2, is the maximum we can produce windows is 12 divided by 2, that 6 windows. That is the maximum windows that we can produce. And the maximum door that we can produce is 4. Okay, and in the plan 3, that is the complicated, because in plan 3 we need 3 hours to produce door and 2 hours to produce windows. So the hours used is 3 times by the number of doors plus 2 times the number of windows, and then it must be lower than the hours available. That is the available resources. Okay, so the subject here is to model our limited resource that we have. And the resource that we use to produce the product here, door and windows. Okay, you know about this equation? Okay, how about this equation? Where does it come from? Why the door must be greater than 0 or 0? Why the windows must be greater than 0 or 0? Because we cannot produce the doors in negative. What does it mean about the negative? We produce the negative number of windows. It is impossible. Okay? So we must produce 0 or positive. There is no negative. Because that is the real. The door is the real stuff. So it must be positive. We cannot produce the windows negative. No, we have to produce in positive. Okay, so we state this equation. Door must be greater than 0 or equal to 0, and the windows must be greater than 0 or equal to 0. Okay, and then from this equation we will present it, or we will plot it in the graph. We plot in the graph. Yes, that is our graph. We have two axis here. The horizontal axis is the doors to represent the number of doors, and the vertical axis to represent the number of windows that we produce. So we have the point 0, point 0, that is from this equation. And then we have the point here, the t, it must be lower than 4 or equal to 4. So we can plot in t equal to 4. That means the t equal to 4. T equal to 4, the t equal to 4, this the line, this line. This line is t equal to 4. How about t lower than or equal to 4? That means the area that's lower than 4, this area. Okay, so we can plot in the t equal to 4. Okay, and to plot the equation of 2v equal to 2w equal to 12, or 2w less than or equal to 12, we can plot the line that the w equal to 12 divided by 2 or equal to 6. So we get the line w equal to 6. That is the line, this line, w equal to 6. And then the w lower than equal to 12, the 2w equal to 12, 2w equal to 12, we can see the area below 12 divided by 2 or below 6. You can see this area below the 6. That is the 2w lower than or equal to 12. That's area. So we just find w equal to 12 divided by 2 or the 6. Okay, no problem to find this line and this line too. For t equal to 4 and w equal to 6. And how about this equation? How about this equation? How we find this equation? We find this line in the graph. We can use when t equal to 0. When t equal to 0, w equal to 18 divided by 2 or equal to 9. When w equal to 0, then the t equal to 18 divided by 3 or the 6. So we get this point 0.9, that is the t point w, and then this 6.0 or t point w. We can say this t point w. The coordinate is t point w. Okay, we got the point 0.9. 0.9, it must be here, and then 6.0, it must be here. So the line is this. I presume the line is this. Okay, that is the area of t greater than 0 or equal to 0 and w greater than 0 or equal to 0. Okay, and then we combine all the area. That is the t lower than 4. That is the t w lower than 12. 2w lower than 12. And then that is the 0.9, and that is the 6.0. Okay, 0.9 and 6.0. That is the 6 is t, and then the w is 0. That is the t is 0, and the w is 9. So we can plot this line. That is the t point w. Okay, and we can combine the area. That is the area, and that is the area of t lower than 4, and that is the w, 2w lower than 12. So the area is here. The area is here. The area is here. Okay, that is the area. From this area solution, we can draw the area solution using another color here. That is the area solution. That is the area solution. That is the area solution. Okay, assume this is straight line, and then that is the area solution too. This is the area solution, and this is the area solution. This is the area solution. So I mark the area solution here. Okay. From this area, you know about the potential solution. Where is it, the point of the potential solution? You can find this point A. You can find this point B. You can find this point C. And you can find this point D. Okay. How about the point B? Point A? A is 0.6. Yeah? A is 0.6. And how about the point B? Point B is 2.6. And the point C? Point C is 4.3. And the point D is 4.0. Okay. And how you find the maximum solution? How you find the maximum solution? The maximum solution is the profit. What is the model profit of we have? The model profit of we have is, okay, we see again, that is the maximum profit. 300T plus 500W. We can examine every point here. Profit in point A. That is the 300T plus 500W. In point A, we have 0.6. So 300 times 0 plus 500 times 6. How many is it? That is 3,000. Okay, the point A is 3,000. Profit in point A. How about the point B? Point B is 300 times 2 plus 500 times 6. That's equal to 3,600. That is the point P. How about the point C? The point C is 300 times 4 plus 500 times 3. How many? 1,200 plus 1,500. So equal to 2,700. Okay. How about the point D? Point D is 300 times 4 plus 500 times 0. So that is equal to how many? 1,200. So we get this 3,000 for point A, and then 3,060 for point B, and then 2,500 and 700 in point C, and then we got the point D is 1,200. So what is the maximum profit? Where is the maximum profit? Exactly, the maximum profit is the point B. Okay, that is the maximum profit. So we have to produce two. We have to produce two doors. That mean is we have to produce two door equal to 2, and the windows equal to 6. That is the optimum profit using the graphical solution. Okay. Yes, that is the sample for you to understand about the graphical solution in linear programming. And I want you to solve the problem using, yes, the optimum solution is here. That is the graphical solution using the graphical technique. Okay, how about this? This is the area visible region. That area visible region. This is that area, the visible region. You can mark the point here as I illustrated before, that A, and that is B point, and that's C, and that's the D, and that is the visible, and this is the profit equation, and you got this, the line of the profit, that is the line of the profit, and you can move the line in the parallel lines, and you will get when the area in maximum is the area is lower than this point from the parallel line of the profit model. Okay, but we can use to find the solution like this, like I show you before, to calculate every point is no problem. When you can calculate every point, you will know the profit, the maximum profit. Or you can find like this using graphical method, and the optimum solution is 2.6, or the 2 doors and the 6 windows. How many profit here? $3,600. Okay. We can give you summary of the graphical method. The firstly, you must draw the constraint boundary line, the subject too. For each constraint, use the origin or any point not on the line to determine which side of the line is permitted by the constraint. And then find the feasible region. That is the second step. You have to find the physical region. That is the feasible region. That is the feasible region. Find the feasible region. That is the feasible region. And then determine slope of one objective function line. The slope of objective function. That is the objective function. And then move straight line 8 with the slope through the feasible region in the direction improving value of the objective function. Stop at least at the last instant that the strike edge still pass through a point in the feasible region. This line given by the strike edge is the optimal objective function line. Okay, the feasible point on the optimal objective line is an optimal solution. Okay, that is the summary of the graphical method. Okay, I think you can draw, you can imagine how to solve the optimization using linear programming, using graphical method. And I will give you tasks for show your ability about this technique. Okay, I give you problem here. Okay. Yeah, okay, that is task for you. The profit and gambit go. Okay, management has decided to undertake a major advertising campaign that will focus on the following 3 key products. They have the three key products. Stain remover, we can draw is SR, and then liquid laundry detergent, we can LL, and then power laundry detergent, we can power laundry or P. You can abbreviate S, and then this L, and then this P as the symbol for your model, okay, for every product. And then the campaign will use both television and print media. There are 2 resources here, the television and print media. The general goal is to increase sales of this product. That is the goal, increase sales of this product. Management has set the following goal for the campaign. Sales of stain remover should increase by at least 3%. Sales of the liquid detergent should increase by at least 18%. And then the powder detergent should increase by at least 4%. And the question is, how much should they advertise in each medium to meet the sales goal? A minimum total cost. That is the goal, the minimum total cost. So this is the minimation. So this is the contrary from our case before. That is the minimization. In the case before is maximization. We find the maximum. We find the maximum profit. Optimal solution is maximum profit. That is the maximum profit. Okay? That is the maximum profit. But in this year is the minimum cost, the minimum total cost. Okay, we need the information to model. The unit cost of television is 1 million, and the unit cost of print media is 2 million. So that is the TV. We have the variable here, the TV, and the print media. And we have the three products: stain remover, liquid detergent, and powder detergent. And we need to the total cost as cool. That is our cool. Okay? So, how you can find the cool? How you can find the cool? That is the limitation or constraint. That is the variable in the graphic. You have the graphic here. Print media or television. Okay, and this is the line of the constraint. Constraint. The line of the constraint here and here. Okay, please write your answer and submit your answer in the task in the my school ID, myschoology.id. Okay, thank you very much for attention, and that's all. Assalamualaikum warahmatullahi wabarakatuh.